morning.
Hey, good morning. I'm sorry, I was been here the whole time. I didn't know it was past time. Well, just taking some. Hey, Vinayak.
Yeah, hi Lee.
Hey,
Good morning.
morning. I'm putting way too much of an I in the last part of your name.
It's Shinde.
Oh, okay, Shinde. Yeah. Well, no, I mean when I say Vinayak,
Mhm.
I'm saying I'm putting too much of an I. It's more like Vinyak.
No, you
No.
got it right the first time.
Oh, nice. Okay. Good. All right, good. Man, boy, I was talking with well, even her first name is, but I was talking with Shridhi, and she popped my bubble, and she told me like, just that I don't know, half to most of the names that I'm enunciating are about, aren't quite there. And then she said, well, technically, like her name is more like, oh man, it's more like shitty. I like the R is less like.
Shireti. The R is the let's see, like r.
I see. Oh boy, that I don't think I can.
Yeah, I think it's difficult.
The thing is like I'd be willing to give it like some healthy practice. It's just that name in particular, it's so dangerous. It's so. It's just. Nice. Well, Abhishek is with us. Vinayak, whose name I can enunciate with confidence now, is with us. So Abhishek and Vinayak, we were able to kind of ad hoc meet for a little while yesterday to review some progress that, some initial progress that Arip had made, and then kind of a second crack at that Nitish has done, and has essentially, I think the team has arrived essentially at a skeleton of, the initial structure of what not just MeshSync probably looks like, but and Nitish, maybe you want to describe it.
Yeah, so essentially around the code structuring and how we set up the Meshry operator repository so that we can basically treat it like a monorepo for all the components of this Meshry Kubernetes deployment, which kind of include the MeshSync piece. You have some policy engines, and you have a whole bunch of other components that we'll be building out. But the idea being that we can share the code across all of these projects. So we've started with a skeleton for MeshSync, and Adeep is going to fill out some more bits for syncing Istio. But yeah, we're building on that. There's going to be certain patterns to use in terms of identifying a mesh. So it's still alpha, so it'll keep changing. So yeah, it's essentially what we have. You can take a look at the link Lee sent. Maybe we can enhance the README and start describing the directory structure.
Makes sense. I'm gonna try to move some of our conversation to the bottom of the doc. I'm gonna try to help clean up our doc some concepts. Yeah, and so to the extent that we ended up using something like OPA as a component, or maybe the component for the policy engine, OPA can be, OPA would fit inside there, right? Because it is deployable in a couple of different ways. I thought you could. It's been like 2 years since I earnestly looked at using it. but we had treated it as a library, as a package last time that we went to go use it.
Mhm.
So, okay. And then maybe I'll poke Adib and see if he's joining. If I could, yeah, there we go. So Vinayak, you had, there was a couple of research items that you were looking into, and I think you'd made a comment recently.
Yeah.
On some of your findings. Do you want to talk?
Yeah. So it was around sharedInformers. Tries to reduce the number of API calls to the Kubernetes API server. That was our main concern, right? Are we going to overload the Kubernetes master or API server with a lot of queries? So the job of sharedInformer. So at the end of the day, it's going to be a single watch, watching on Kubernetes API resource, API server for the resource updates, and multiple controllers along with our own controller will get the update for that.
Yeah, I think that's what we've settled on. Adeep is going to do that for listing CRDs right now. Like the kubectl gets CRDs. So we're going to start there so that we can look for istio.io CRDs to signal that Istio is running on the cluster. But yeah, we'll stick to shared index informers.
Yeah. So we initially had a concern: is it going to load the API server, or how it's going to affect?
Yeah.
So I tried to answer that.
Yep.
That makes sense. And so that's essentially the design of Kubernetes itself. And that's the design of a sharedInformer that, I mean, yeah, there's a, yeah. There were kind of two parts to that conversation, I think. One was, hey, how do we efficiently, how do we perform this efficiently in large environments? Another one was, or part of that was, how do we prime the cache very quickly, but while also not overloading Kubernetes?
How much does performance matter with respect to MeshSync?
It might, well, there's a couple, there's two ways in which I think it could be an issue. One is, when you think about it in context of a piece of management software, look, like here's a relatable example is like, you're using a network management system. It's using SNMP as a protocol to look at resource utilization of a switch or on the device. And you set it to poll once every minute or once every 30 seconds. And at some point, the management system becomes the issue because it's asking the device so often, like, hey, how much free memory do you have in your routing tables? And turns out, like, the small program that runs to figure that out takes a little bit of resources. And so in concept here, so we were just trying to be on guard about something like that. Like, hey, if we're, now granted that's a polling system, this is more eventing. And so the system itself, Kubernetes, is a bit more in control about how quickly it's going to respond. If there are, if there are thousands of objects, we may not be interested in all of them. But if we're also trying to design a system in which the user ends up feeling like they're getting pretty much a real-time perspective of what's transpiring when we're sourcing, if we're sourcing some metrics from Prometheus, maybe some logs from somewhere else, and then just updates about objects and their status and deployments and things. But yeah, I don't know. Yeah, it's good for us to have to take a look.
Yeah, but I still think sharedInformers would be fine for the use case, because you basically in this use case I'm just talking about the MeshSync controller. His job is he's just a scanner, so even if there is a delay in the sharedInformer, like a couple of milliseconds, it shouldn't be a big deal.
Nice. Good deal. Yeah, these were questions that we'd raised up. I think just before on a call in which one of our early calls, I think before you were on, and it was just us acknowledging like, okay, hey, how do we? And I guess in some respects, to what Vinayak had just how you were just describing how sharedInformers work, or well, is a sharedInformer with a shared index? Is that the right? Or is it sort of one and the same? sharedInformers have.
They're pretty similar.
Okay. That even if there is like, let's say that the delay goes up to 10 milliseconds, or like, we get we're seeing worse performance than we otherwise were. That's not likely, or that really actually shouldn't be. I was going to say it shouldn't be an artifact necessarily of MeshSync, because that's a job that Kubernetes is having to do anyway. Now, that said, hey, if no other now I'm going to use the wrong terminology, but if there's no need for Kubernetes to be running running informers for a bunch of objects that it otherwise wouldn't be informing on, then I can see us, adding a small overhead.
No, I don't think. I think it's pretty efficient. I mean, it's a very. I guess I shouldn't have raised this point either, because sharedInformers are pretty performant.
Okay.
So, I mean, the other alternative is overloading the API server with watches.
Yeah. And this one's more, so I guess maybe, yeah, say more. Like it seems like this one would be more performant, the sharedInformers.
Yeah. And the resource usage is lower, so.
Nice. It sounds like it's about as good as it probably gets anyway. It sounds like, Kubernetes itself has been designed in consideration that there's other systems that you need to know what's going on inside of these control loops, and that it's designed to inform as many others. And like in some respects, if there's 1 to 10,000 process like subscribers for a particular update on an object, that the overhead there is negligible between 1 to 10, because it's going to send out the same event either way.
Mm-hmm.
And so, yeah. So, I mean, I'm not sure if there's, other than like shared memory. Like.
So another question, Lee, Vinayak, what do you think are the mechanisms for identifying a mesh? We've recognized CRDs as one. The other two are not concrete, but we were thinking of searching for deployments and then searching for images to figure out what version we're running. is there anything else we might use for? So I everything I say is from a very Istio-centric perspective because I haven't played with a lot of other meshes, but that's something someone has to take on and say, this is how we can identify Kuma, this is how we can identify Console Connect. So if there's a common pattern to these things, then we can build out a fingerprinting package and an interface that we can reuse or use across all the meshes. But I do want to abstract these things out. And you can use the builder pattern to say the first one is fingerprint with CRDs, the next step is fingerprint with deployments, and the third step is fingerprint with images, and that fills out the final object model saying that we know it's present, we know the control plane's running, and we know the version. Something like that. Like we'll have to build a model, an object out of what comes out of it.
Is the builder the builder pattern, is that a Go thing, or is that you just mean like in general, like?
It's in general. So
Okay.
it's what I pasted on Slack.
Sure. You don't have to. That makes sense. I was just wondering if it was like a specific.
Yeah. So it's not. I mean, it is used in Go. Kubernetes does this a lot, but the alternative is the options pattern. But I feel with options, it's not going to be that clear. Options is great for setting up config values or some structure values, like in addition to the defaults or overriding defaults. The builder pattern is essentially we're saying fingerprint on CRDs, whatever result you get, fingerprint on deployments, images, and we can just chain all of these in order.
Nice. Yeah. Well, okay, so let's think about that for a minute. So what makes one mesh different from another? So, I mean, there's different deployment models, some of them sidecar proxies. And so if you're looking at a service, you might find a proxy in the same pod, right? That's interesting. That doesn't, I mean, granted, if the proxy's image name is Istio proxy,
right,
it's probably,
right.
Now,
the other thing, Lee, is that it could be that the mesh has not deployed any sidecars yet. So you can't assume that there are custom resources deployed or there's sidecars injected. So you'll have to base everything off of the control plane.
And so this is, yeah, totally. And that specific example that I was giving is a good thing to examine so that you can answer a different question, which is more or less the thing you just said, which is, hey, what services are present? And of those that are present, which ones are on the mesh, which ones are off the mesh? And part of the concept of, or what you were articulating earlier about sort of tiered discovery is like, that's one of those subsequent questions that you would kind of ask later in some respects. It kind of, I mean, it actually does matter eventually if there's no control plane and yet there's some proxies that are clearly Istio proxies sidecard to, and it's like, hey, you've got residual artifacts of a prior deployment. Okay, you have an issue, but and so yeah, so identify. So the question then, how to what are the most common?
So let's focus on Istio. I think CRDs is going to be one of them because all the meshes that use custom resources, we would just do a kubectl get CRDs and search for the Istio IO. For say for Istio, I think once we have identified that Istio is the control plane is running, we can kind of integrate the Istio ctl, Istio CTL code, and basically like what Istio CTL does with version that could be used. Actually, we could start with that too. We probably don't even need to look at CRDs. you could just integrate a search for Istio is basically using Istio CTL.
That's,
Why reinvent everything, right?
yeah. That's exactly what I was going to say when you were done talking. Yeah, yeah. Only unless they're doing something really, like really stupid or something. But even at that, like obviously it works for, and the thing about, and like the thing is like even if it is, was retarded, that, well, they're going to guarantee that they're going to sustain that retarded implementation. They're going to make sure that it works from version to version. So.
Yep. I think, yeah, it might be a good idea to just go with that instead of but yeah, we should still, like what Adeep is doing. We need to expose that function so that we can use it for more types other than CRDs or whatever. So we have this module that we can use to create shared informers when we need it. It might not be urgent. I think the first step would be, now that we think about, is using the Istio CTL approach, so we can import their package and just basically invoke that version command.
Yeah. It is, Jim. And then we will find, like in Istio's case specifically, because they are putting so much oomph behind Istio CTL, that it is the case that there may be some other, or there are a number of other functions, commands that they've included that, yeah,
that we could leverage.
Now the linkerd, hey, not dissimilar in that the linkerd utility, the command line, does quite a bit of, like they expect that you're installing using that command line as well. I think the issue with both of these is I think that there's an Istio, and I get, well, so there's an Istio CTL Go client, or no, that's the wrong ways. There's
a Go package for it.
For the CTL, or for
the CTL is part of the Istio repository, so you can basically just import that code. So if I just look at Istio CTL and the Cobra commands, whatever it's invoking, I could just invoke that version function, or if they expose one. It's probably an API. It's probably a REST call to Pilot, and Pilot responds with the version. So with Linkerd, it's going to be the same. The CLI is talking to the Linkerd control plane. I forget what it is, the API server that they have, and that's responding with the version. So I think that might be a good way for things that we know we can leverage their own packages. Where we do not know, we invent our own.
Here's a brain tickler, maybe, is, I mean, yeah, and like some of these questions that I ask are, they're in, I mean, some of these can be set aside because, like, hey, look, that's too tough. And so, note taken, and we'll move on. But so how do we support or understanding that methodology may change from, and maybe it's like the likelihood so low that it doesn't matter, but from Istio 1.0 to Istio 1.7, let's say that it did change 3 times in those versions, and so we wanted to support going back that far. What mechanisms are there for dealing with importing 3 different versions of the same package?
They are backwards compatible. That's a guarantee that Istio makes with the SEM versioning. So if they don't, we open a bug, because that's that's a breaking feature, unless they go to Istio 2.0 and then things change. But as long as they're in the 1. version, we can assume that everything will be supported. We could use the master branch or the last stable release and keep upgrading if we have to. But I think we can assume that it is backwards compatible. They don't get rid of, let's say, objects like, can't remember, I think authentication or whatever they had.
Or like Mixer
Policies
together.
thing. Yeah, yeah.
But well, and that's a good yes. I like that answer. It does put assign faith to. Let's say that they, okay, like you're saying, they don't. We can go file. We can go ask for them to do something. To the extent that they are never going to, and it was a major issue for us, and we said we're not going to use. Like, one thing to do is that we fall back to more generic patterns of like doing grabbing all the CRDs, looking for Istio something, and then which can be written up in kind of the tiered discovery model. But is it this is coming from a place of ignorance, if you can't tell in some of these things, is it possible to import the same package at different versions? Like,
yeah, good question. No, I should take that back.
I think
Because of the, sorry, go ahead.
In general, Go packages themselves maintain the version in their path, right? So there will be /v1 / so like github.com/k8a/ or stio/v1 and then v2 v3, so that same package in the different versions can be implemented or imported. But that's up to the maintainer of the package, how they are doing that. But
I don't, Vinayak, I don't think that's possible because of how GoMod works. GoMod work is going to pick up the minimum, I forget what the word is, compatible package. So if you give it 1.5 and 1.2, it's going to pick 1.2 as the version. So that's how GoMod works.
here's this item. This is curious.
No, that's just it's gonna do your go get for that release version, and then basically in your go sum, it's gonna add the checksum, or actually, yeah, it's gonna add the version that it's using. Sometimes it uses the commit SHAs or the checksums. So yeah, that's what I was referring to. Is, let's say we import client Go, and we also import another third-party package which depends on client Go. So we could be asking for 1.4, but they depend on 1.2. So since we have to support both, it'll pick 1.2 because of the SEM versioning. It's assumed that it's backward compatible. So they would pick whatever. I mean, it would pick the minimum that's supported across both of them.
Gotcha. Oh, got it. Okay. Is this the last time that someone had looked at this? It was either that like there wasn't enough support for things that we were trying to do, and so I guess I'm wondering with some of the dates on. I wonder maybe some of these libraries don't need to be updated necessarily from release to release. Okay.
Yeah, they probably don't. The only thing they're going to change is, yeah, that APIs.
Okay.
So previously they used to use protobufs, and that was becoming a problem. So Aspen Mesh created the client Go that Neeraj had set up, and I remember contributing to it, and then so that we can support it with the operator framework, or like building our own operators. So so then they brought in the Aspen Mesh client Go and made it part of Istio client Go. So now they actually support more native types that basically implement all the methods that make it qualify as a custom resource.
Okay. Huh.
So they might not have every type, but I don't think that's a concern initially for us.
Okay.
But I think they have everything now. I mean, they need to because of the whole operator pattern that they have. they have picked up, but I could be wrong.
So educate me if you would. So this, we're looking at a client Go package for interfacing with Istio. In here, under the APIs, well, I guess is the packet. I guess I'm not under APIs. Client Go package informer. What's this? How relevant is this to what we're talking about with?
It's an informer for their custom resources. I don't think we need that. Like I said, the custom resources may not be deployed, even though the control plane is running. So I think it's better to query the API server using that istio-ctl, whatever they use under the hood, and
Sure.
I mean pilot, and ask pilot what version are you running? Are you up and running? Or whatever information it gives back to us. We massage that information and kind of convert it to our abstract model or object that we want to use across meshes.
Nice.
So
sounds good, or perfect. Actually, my question here is more just one of learning, like
oh, okay.
Just in general, like, hey, I'm just learning about shared informers, and I'm learning more about the. Anyway, it's just more of like, what are they doing here? What is this?
They're doing the same thing Adeep was going to do. They've just created a package for it so that they can reuse it across different places. This is probably for the sidecars, where the sidecars could be watching for resources. I don't know, whatever this is. But
Okay.
yeah, we're going to take a similar model where we were thinking that you would have PKG. In this case, they have informers. We would have a similar directory and blah blah blah. I mean, this is just they made it modular so that they can follow the drive principle and they don't have to basically reinvent everything. So
Nice. Okay.
but if you're interested in learning about shared informers, there's a lot of articles around it, and I'm sure Vinayak knows some where they give you the diagram, like it's illustrated on how things are watched and added to the cache and how events are created. So I think you can, if you just search for shared informers Kubernetes, it'll talk about it.
I'll get it back.
So,
Okay. Got it. Nice. And then, so for the most part, like the purpose of probably that code that we were just looking at and kind of the client Go in general is more so to facilitate the Istio operator.
yeah,
Is one use case.
or any other operator that depends on Istio. Like when I wrote an operator at Affirmed that wanted to basically list virtual services, we used client Go, because client Go had the virtual service dot list or dot watch or dot get option.
Gotcha.
Because it implemented that regular interface that Kubernetes asks custom resources or their types to implement.
Gotcha. Okay. So to your ask, there's a little bit of thought to be given. That is not a critical need at the moment, but a little bit of thought to be given to a builder pattern for achieving potentially, composite fingerprints. The initial use case is for identifying the fact that a mesh is deployed, although that builder, to your point, like, that builder pattern probably isn't totally necessary for identifying the control, or probably not, based on some things that should just be available, but maybe in the future about answering a lot more intelligent, or deriving a lot more intelligent insights that, like, yeah, I don't know, you're running two different. You've got multiple versions of the proxy of the proxy running in a given mesh, or whatever those things are. But, okay. other things that we need to, so. Okay, there's a couple of things, two things that might end up going by the wayside. And one that I would think would be the first to go. And that's that there's two things in Meshery today that kind of achieve similar synchronization with Kubernetes, but the architecture is not good. And so, and this actually probably needs to be turned into a user story to see if MeshSync can just achieve it for us, or see how it achieves it. And that's the notion that every time that you go to run a performance test from Meshery, that there's the need to snapshot what the environment, what the infrastructure looks like at that point in time, so that can be snapshotted and persisted along with the results of the performance test. And so there's a small set of Go that will go over and use the Kubernetes client to, do an assessment of the environment. I think we looked at this another time, but basically what I'm saying is like this would hopefully go away in the face of MeshSync.
Yeah, most likely.
And so if
we could use that package and we'll package everything in here so that the adapters can use it or Meshery can use it.
Nice. And then, and then you just highlighted the second area that will hopefully be positively impacted by MeshSync, and that being the architecture of the architecture of the adapters, which maybe the architectures that they still are, separately deployable adapters, but that are, much more leveraging MeshSync, or that it's possible that those adapters morph into a component inside of the Meshery operator. Anyway, just kind of talking out loud since we've got Vinayak and Abhishek here, because I think of, our Abhishek had to go, but Nitish, of the things that I think the path that Arip is on, and that you're kind of tying off right now, does make a lot of sense. What asks do we have of Vinayak is what I'm trying to explore.
So I'm curious about, so Linkerd and Istio, we're kind of saying that have a similar approach because they have their own client. So I'm guessing they have their own packages because it's all Go repositories.
No, Linkerd doesn't though, is the near as we can tell. I think Asuko's been trying to dig into using to leveraging just that, and has been coming up dry.
So leveraging the Linkerd CLI's code?
Right. No, it's not that he can't go take, it's that they didn't have it. What's the right way to make my, they didn't have it. They don't have a client Go. They do have packages.
Oh, no. We don't need a client Go. So client Go is only meant for let's say, solutions that use custom resources. Linkerd does not use custom resources. The thought is that we basically want to dissect their CLI tools code and see what kind of API request it makes. So I'm pretty sure they must have abstracted a lot of that. So it's basically diving into what the code flow is for Linkerd's CLI, and everything's written in Go other than the data plane. So it should be pretty easy to follow through and say, this is how we can import their package and make the API call to the API gateway or server for Linkerd. And I can try drawing some diagrams around that. But for Vinayak, I'm curious if we can start looking at something like Kuma or Consul? Is it a similar approach? Do we have CLIs for them? Are they written in Go? But Linkerd and Istio are the common ones, and there's a lot known about these guys. But what about the ones like Kuma and Mesh? So just curious, like what their repositories look like. Is there any code that we could import and use? And what is their way of identifying like their version command if they have a CLI and what it does? So that way, either we find a common pattern or we say that each one has a unique way of querying. Maybe we'll have some tiered approaches where we say look for CRDs or look for images or look for deployments, but that's not our primary method of fingerprinting a mesh. The primary should be that, hey, can I talk to the control plane? Is there a control plane up and running? If the response is like timed out, there's no control plane. If there's a response coming back, then there is a control plane. Rather than reinventing things is what this is gonna help us speed up the MeshSync development. I know we were discussing CRDs and other ways of listing, but this just came to my mind that we don't need to.
Totally. Yeah, it makes a bunch of sense to me. Vinayak, have you gotten, is this the right excuse that you need to put your hands on Linkerd and Console?
Sure. So so Consul is one thing. What the second one should be the Kuma, or which one?
So Vinayak, let's do this. Let's tackle Linkerd and Istio at the same time. So me or Adeep could start tackling Istio. You could start tackling Linkerd and look at the code on how we can do. We can query their control plane and ask for the version or get any other details we need about that mesh. So that way we can divide and conquer and do these two primary service meshes that we want to support. And then if someone else jumps in or we have time, we'll start looking at Kuma and Mesh and Console. So if there's a third person, maybe Adeep or me jumps into Console and starts looking at that as well. So we're basically tackling each of these meshes in parallel. So I'll try to get the abstractions and the interfaces ready so that all we have to do is focus on the business logic and then just implement those interfaces.
Sure. So I'm just reiterating my understanding. We need to look for how these individual mesh CLIs are able to identify or talk and connect with their own control planes, and can we leverage that same logic in our MeshSync to fingerprint the meshes, right?
Yep. It would be ideal that we can import their Go packages, go get them. If we don't have that, we'll have to basically mimic the API calls that they make.
Sure, makes sense. Yeah.
I don't know if they have certificates and everything. I highly doubt that these CLI tools have too many certificates that they exchange. But yeah, we can see what happens. So yeah, it's research work, and then we can basically see how we want to do this.
Yeah, makes sense. Yeah.
Gents, nice. Does that mean we're ending early?
Yeah. I think we have things to think about. So I guess I don't know. I'm trying to think out loud how we want to divide responsibility. So we discussed Vinayak takes on Linkerd. Adeep probably could take on Istio, and I can initially do the architecture of or just lay out the skeleton code, the interfaces, and how we want to structure repo, and then jump onto a third mesh. If console is a higher priority, we'll jump on console and I'll start doing the same things that Deep and Vinayak are doing so that we can just move from mesh to mesh. And discussion we will need to have is what's the MeshSync model object, or struct that we want to use to the abstraction that tells us about the mesh. So it just needs to tell us, is it up and running? What version is it running? Any other information that we need to know, which is common across meshes. They don't have to be unique to a mesh.
Number of proxies, number of,
Right.
some reason.
Some configuration elements that we'll need to know about the control plane, and then maybe like in Istio's case, there's the sidecar config map. So we want to figure out what the sidecar Envoy Bootstrap config looks like, or the commands that they run, or whatever.
Nice. Okay. This is good. Vinayak, any other thoughts?
No, I think we should go with this path only. I told.
Vinayak, if you think about it, if you can, I'll message you his name, Asuko, will be interested in some of your findings, I think, on Linkerd, in part because you were trying to find a more intelligent way of provisioning Linkerd, which would also have to do with like leveraging the package inside of its CLI to provision it. So.
Okay. So can you just Slack me his name?
Yeah.
So I need to reach out to him. What I couldn't get it.
Or rather, just be social and include him in your findings, or
Okay.
if you, and
Yeah, understood.
nice. All right, Nitish, same time next week.
Yep.
We're on a roll. We formed, stormed, normed. We might start performing here quick.
Yeah.
Cool.
All right.
Yeah. Thank you, gentlemen.
Yep.
Okay. See you guys.
Bye.
Bye.
Bye.